Hello everyone, I'm JHacker, founder of Exploity. Today we are going to be talking about hardware security, and I have with me Alex Plaskett, security researcher from the Exploit Development Group at NCC, and Robert Herrera, senior security consultant at Hardware and Embedded Security Services Group within NCC. Welcome, folks.
Thank you. Happy to be here.
So let's first start with your latest research on Sonos devices. I assume you found quite juicy vulnerabilities, critical vulnerabilities in the devices. So why don't you tell us?
Yeah. So I think it's twofold. So I'll go over the actual Wi-Fi portion, and then we'll go over the secure boot portion. But really, the long and short of it is we found a bug in the wireless kernel module that's in charge of parsing Wi-Fi messages going over the air in the Sonos device, namely a MediaTek Wi-Fi stack implementation. The root of the actual cause is really just a lack of input validation, namely on information elements that are getting parsed by that, let's say this kernel module. And what we found was a memory corruption vulnerability, or really just a classic stack buffer overflow that we were able to leverage due to the lack of security mitigations. So that's kind of like a rough overview of the bug itself. Like I said, the actual lack of security mitigations enabled us to go rather quickly, from vulnerability identification to full-out exploitation. That's pretty much an overview of the Wi-Fi portion.
Yeah, and I guess to add to that as well, like how we're demonstrating exploitation as well of the Sonos devices is where we're turning it into like a covert wiretap or listening device. So we'll basically record all of the microphone conversation within their room. So after we've done the exploit, we'll basically like record everything, and then we can capture that and play it back, for example. And the second main vulnerability is a vulnerability within the secure boot chain of the device. So when the secure boot chain does its validation, there's a flaw in one of the functions, which it's a programming mistake, which essentially we've exploited this to kind of override the validation checks and load our own custom unsigned code at boot time. And then this basically gives us a full control of the device after the device boots up. And it's also persistent as well. So so you can flash it to the device, and every time you turn it on, it basically, the device is kind of exploited. Yeah.
Nice. So are these the wireless vulnerabilities? Are they in the protocol parsing within the kernel?
Yeah, that's correct. So they're the actual, the kernel module is really just an implementation of the essentially the 802.11 protocol. That's correct. Yeah.
Okay. And so, do the devices use a proprietary operating system? Is it just bare metal, or do they use Linux?
This is a Linux distro, running under the hood.
So they had Linux, but they still didn't activate the mitigation strategies.
That's correct, yeah. So within our presentation, we go over things like the lack of, let's say, KASLR that wasn't enabled.
Yes, exactly.
Yeah, exactly.
Mm-hmm. Oh, nice. All right. So you guys have done a lot of pontoon challenges as well. Do you have any advice for researchers in terms of what are the effective ways, or what is an effective process or methodology when you go about identifying vulnerabilities in embedded or IoT products?
Yeah, so I think the way I tend to go about it is I first do a lot, like after I've kind of gotten through the targets in the competition to see what the targets are, I would do a lot of extensive background research into each of the targets, and then see which one, if there's published research there before, if there's been vulnerabilities found there before, and get a kind of understanding of what I think the security posture will be like. And then once I've got this, I'd purchase the devices, and then I would start doing my kind of bug hunting process of actually finding the vulnerabilities. I can talk about that So basically, the two main processes I use, I do a lot of reverse engineering for binary analysis, reverse engineering with custom tools to automate that process and speed it up. I also do a lot of code review if it's open source, And I quite like fuzzing as well. Like fuzzing's, I find is a good. You can develop the tools like before you're working on them, and you can share them between like different devices, different protocols, and things like that, and then build up this kind of knowledge and tooling over a period of time, and then apply that to finding vulnerabilities in different devices.
So there's a lot of I shouldn't call it hype, but a lot of people are now identifying vulnerabilities in hardware as well. But from the other side, the vendors, they're typically of the mindset that hardware vulnerabilities are difficult to exploit. So I want to know from you, when you go about identifying different vulnerabilities, how do you use hardware vulnerabilities and leverage them along with software vulnerabilities to basically compromise the devices? And are they really critical, or it's just hype?
Yeah, so one sort of step in kind of point-to-own process, or the process we use for exploiting devices, is we do a lot of like hardware teardown, to start off with, and that especially if you're trying to like exploit a memory corruption issue, you really need to gain some kind of debug capability or visibility on the device itself. So that's often the first stage, is things like identifying debug interfaces, getting a shell before you can actually do your exploit writing. So that's why we did the secure boot hacking first, was so we could get access to the device to find additional vulnerabilities which we could use remotely for the competition. So to answer your question, I think hardware vulnerabilities are as critical as well as software vulnerabilities. It's just that you need to have a holistic approach to security. You need to consider both software and hardware, and if one area is a lot weaker than the other, then the attacker will just go for that. So yeah.
So one of the things that I see with manufacturers is that they put a lot of trust in hardware. So by trust, I mean when they're developing their firmware on top of it, they do not look at a lot of things like debug ports open, for example. And this kind of reminds me of the state we were in the 90s with software security. So what do you think about the state of embedded security right now? Are we really in that stage where people are just not aware of how they can get hacked from hardware, or what are the hardware issues?
I think there's obviously different levels of maturity, of security maturity between vendors. You've got some who are we don't have as high a security posture as others. And I've seen recently when we were doing point-to-own automotive, we were finding things like debug capabilities not being disabled, like kind of basic mistakes. But then on the flip side, you've got vendors like Sonos, which you'll see in our talk, they've got full flash encryption. They've got all the most of the debug stuff disabled, and we're also seeing vendors investing more in hardware security and hardware security mitigations, in say CPU architecture. They're implementing things, and so I don't know what you think about, if there's anything to add to that.
No, I don't have much else. I would say that the main takeaway is really just a a spectrum of the level of security that some vendors have. Some vendors are going to have a lot more mitigations, and really just I want to say just security controls that are implemented into their system. And others are going to have a more sort of rudimentary, maybe more reactive approach to their security as well. But yeah, that's pretty much all I have to say regarding that. Yeah.
So there's a lot of buzz about supply chain security, especially in IoT and embedded as well. So do you have any advice for enterprises or manufacturers of top 3 or 4 things that they can do for an effective security against supply chain issues?
Yeah, that's a good question. I think a couple things that come to mind are really just at the end of the day, especially with hardware and embedded security, or just hardware, which is really just physical components, you can kind of think of it as really just asset management, or keeping track of where along the process your actual device is, and who actually has access to these devices, and coming up with some sort of secure process of verifying that when this leaves the factory, it hasn't been tampered with. So that's the first thing that comes to mind. The other thing, as far as a sort of a holistic approach to security is concerned, is of course these devices themselves aren't necessarily just bricks. There's going to be software that's running on these devices. So equally, a lot of this software that needs to be flashed onto this device needs to be scrutinized as well. So security audits of this actual, like the code base itself that's being compiled and flashed onto these devices is just as important. So whether it's an internal security team that's actually looking at this code base or a third party, I would say it's another integral part of the sort of supply chain process of that hardware and embedded space. Yeah.
But don't you think it gets difficult with different software components coming in from third party as well as open source, where you really do not have access or control? Like somebody's giving you libraries.
So, yeah, I think it depends on the vendor as well. Like some vendors have access to the third party code which they're integrating into their products, and other vendors are just like shipping binary blobs. And I think as a device vendor, you should be assuring your third party code as well. Like as we've seen, like with the Sonos, that the actual vulnerabilities were in MediaTek drivers, which wasn't a Sonos first party. I don't think it was Sonos developed code. It was MediaTek developed code, and so it was obviously whether Sonos had access to that, I'm not sure, but. So that needs to be at the same security posture as the first party developed code as well. Yeah.
So basically what I can take away from your points is that you really need to do audits and make sure that, your third party, whoever the vendors are, you need to make sure that they're also adhering to security standards.
Well, yeah, and you need to check those standards as well, because there's no, like, if a third party just like attests that their security is good, like, okay, but you need to validate that that's actually like the case as well, which is where this kind of third party validation comes in. And we see this from like the most mature vendors. They're not taking like things at face value. They're actually testing this and checking this. So, yeah.
Yeah, and I think a big component of what attack surface you need to actually look at is informed by threat modeling. So mature threat modeling as far as identifying what attack surfaces are most relevant or most pivotal in your system. And that would be a real sort of mature way of guiding what specific code you're looking at. And I think that sort of approach definitely basically maximizes your chances of securing the most integral parts of your software architecture. Yeah.
All right. Thank you so much for joining us, guys. We were speaking with Alex and Robert on hardware security. This is JHacker signing off from ISMG Studios. Thank you.